Okay, here we go with a fun little video on making equations of lines from a given table. So in example 1, we look, this is your x column, this is your y column, and eventually you want y equals something times x, and then plus or minus something in order for you to get from the x to the y. So look at what is the difference between the y values as you increase. So we go up by 2 every time. What is the difference in the x values as you go from smallest to biggest? So we go up by 1 every time. This will tell you what number goes with the x part. So it will be the difference in the y's, so 2 divided by the difference in the x's over 1. And then you're just going to take a look. Once you know this part, start with whatever your first value is, and now put it into your equation. So you're thinking y equals 2x, and then I know I'm going to need to do something to get to 3 in the end. So 2 times 1 would give me 2. If I added 1, I would get 3, which is what I'm looking for. Then double check, will that work for everything? So if I do 2 times 2 plus 1, that gives me 5, and yes, that's what I'm looking for, 5. So then I know my equation is 2x, and then I need to add 1 to get to the y value. You really only need to check 2 values, and that will give you your equation for your straight line. Okay, you try this one and then you can turn back on the video and we'll see if we get the same thing. So here I'm going up by 1 every time. On the x part, I'm going up by 1 every time, which means my equation will start y equals 1 over 1, which I never need to write in, but I'm always thinking x, and then something's going to happen. So y equals 1 times 1, and then I'd have to do plus 3 to get to 4. So now I'm going to think, is plus 3 going to work? So y equals 1 times, let's do our next one, 2 plus 3, that gives me 5. Is that what I'm looking for? Yes, it is. Oh man, you're so smart. So that means we'll just simplify this guy. We're going to have y equals 1x, and we don't need to write the 1, plus 3. Ta-da! And that will give us any point on our line. Okay, you pause again and give it a try. Here we go. Okay, so I'm going up by 6, up by 6, up by 6. Yes, has to be the same every time. And here I'm going up by 2, up by 2, up by 2. Good. So I know I'm going to have y equals 6 divided by 2 with the x, and then plus or minus something. So y equals 3x. And now let's see what's going to happen for this something. So y equals 3 times, we'll substitute in our first x value, and I'm going to get 6. I would have to take away 1 to get 5, and let's see if that will work with my next x value. So 3 times, I'm imagining substituting back here in for the x, 3 times 4, plus 1, that gives me 13, and uh-oh, that's not looking good. What about this next one? Oh, because I did plus 1, look at that. Okay, that's good. Phew. Take away 1, that will give me 11, that's what I'm looking for. Okay, now just to double check, make sure I know what I'm doing. 3 times 6 would give me 18. Take away 1 would give me the 17. So yes, there we go. Okay, and this, when I was writing it, kind of looked weird because I've got 5, I'm going up by 5, I'm going up by 7, and then I'm going up by 9, but here I'm going up by 1 every time. So this is not going to be a linear function. So I can't make a y equals something x plus or minus something else. Your general form for that, and you'll learn this later, is y equals mx plus b. M is the slope, that's what we just found, that times this to the x. And then b ends up being your y-intercept, which is where it's going to cross on the y-axis on your graph. But if we just do a little sketch of this graph, we're going to be able to see that it won't be a straight line. So 1, 2, 3, 4, 5, and even if we just do scrappy, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Let's see if that's good enough. Oh, let's move the camera over. There we go. Okay, so now over 2 and up 5, over 3 and up 10, and 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 20, and we're at 4 and 17, and 5 and 26, 5 and 26. I don't know, that is kind of looking like a straight line. Okay, so of course that was bothering me that it did sort of look like a straight line. So here's a better graph on an actual graph paper, and if we look, if we connect, oh yeah, it's not gonna make it. And this guy, if we connect, no, that is not going to connect to the other graph. So in actuality, we're going to end up with a curve happening here, which you don't know how to calculate the equation of yet. Woohoo! That'll be another fun year. Okay, hope this helps. Enjoy!